Hey guys, so today we're going to work on standard 76, which is rationalizing the denominator. Alright, so let's do a quick recall from video 74. We had our simplest form rules. If you already have these written in your notebook, you don't need to write them down again. First, what we focused on the other day was no radicands had perfect square factors other than 1. So that was just simplifying down our radical. And that's what we focused on. Today, we're going to focus more on 2 and 3. 2 says that no radicands contain fractions, and 3 tells us that no radicals appear in the denominator of the fraction. So these are the two rules we're going to continue referring back today. Okay, so let's start with the quotient property of square roots. What the quotient property of square roots tells us is that if I have the square root of some fraction, I'll say x over y, so for some number x and some number y, that's going to be equivalent to the square root of the numerator over the square root of the denominator. So for example, if I have the square root of the fraction 5 over 3, that's going to be the same as the square root of my numerator, which is 5, over the square root of my denominator, which is 3. So this also goes the other way as well. This goes both ways. For example, if I have the square root of 2 over the square root of 7, that's going to be equivalent of to the square root of 2 over 7. This is going to be important for what we do today. Alright, a new term that we have, or a new phrase that we have in math is rationalize the denominator. Remember, denominator, remember denominator means the number in the bottom of a fraction. So if I have some fraction x over y, my denominator is that number in the bottom, or in this case my y. So to rationalize the denominator, we're going to multiply both the numerator and the denominator, so both the top and the bottom, by some number that will get rid of the radical in the denominator. So for example, if I had something like 3 over square root of 2, I do not want to have a radical in my denominator. So I need to find some number that I can multiply both the top and the bottom by at the same number that will get rid of that radical in the denominator. So these are going to be our 3 steps when we're working through these problems. The first step is going to be to reduce a fraction if at all possible. Step 2 is going to be to actually find that number to multiply the numerator and denominator by. And then finally, step 3, we're going to simplify. Alright, so for our first example, we need to simplify the square root of 35 over 15. Well, if we go back to our steps, the first step is to reduce the fraction if possible. So since 35 over 15 is a fraction in underneath my radical, I can go ahead and reduce that fraction. So what I see is they both have a 5 in common, so I'm going to divide the top by 5 and the bottom by 5, and that's going to give me the square root of 7 over 3. Now if we remember our newest rule, we know that the square root of 7 over 3 is going to be the same as the square root of 7 over the square root of 3. And the reason why we want to write it like this is because one of our rules tells us that we don't want to have a fraction as a radicand. But now, when I rewrote it as the square root of 7 over the square root of 3, I've broken another rule, and I have a radical in the denominator. So I need to find a way to get rid of the radical. It's really going to be pretty simple, guys. What you're going to do is you're going to take whatever is in your denominator, whatever that radical is, and you're going to multiply both the top, the numerator, and the bottom by that radical. So for example, the radical in our denominator right now is square root of 3. So I'm going to multiply both the top and the bottom by the square root of 3. What that's going to do, on the top, it'll be the square root of 7 times the square root of 3, which gives me the square root of 21, over the square root of 3 times the square root of 3, which gives me the square root of 9. Well, the square root of 9, we know what that is, so what we end up getting is the square root of 21 over 3. And this is my final answer. Alright, example 2, go ahead and write this down. we're asked to simplify the square root of 6y over the square root of 12. Well, our first step is to reduce the fraction, and if any, and so what I'm going to do is I'm going to go ahead and rewrite this as the square root of 6y over 12 so I can see my fraction easily that I need to reduce. I need to reduce the fraction 6 over 12. What I'm going to do is divide both the top and the bottom by 6, and that's going to give me the square root of y over 2. So now I'm going to go ahead and rewrite that as the square root of y over the square root of 2 because I was violating a rule. I had a fraction as a radicand, but now I have a radical in my denominator, which is square root of 2. So what I need to do is I need to multiply both my numerator and my denominator by the square root of 2. What that's going to do, on the top I multiply my radicands 2 and y to get the square root of 2y over the square root of 2 times the square root of 2 is the square root of 4. Well, the square root of 4, that's a perfect square, so we can go ahead and simplify that. The top will stay the same as square root 2y over the square root of 4, which is 2. This is my final answer. What I want you to notice is what I have going on in my numerator and denominator on this problem. My final answer has the square root of 2y over 2 by itself. This is not equivalent to the square root of 2y over 2. The reason why is my denominator is no longer under a radical, so this can't be a part of the same fraction. So this does not reduce to the square root of y. Do not do that. I'm going to go ahead and get rid of this. All right. So example 3 looks a little bit different. If you look at my denominator, I have a binomial. And remember, a binomial is just 2 terms. Before, on my other 2 examples, my original denominator only had one number, the square root of some number. But now I have a binomial, so we have to have another method. When you have a binomial in your denominator, you're going to do something called multiplying by the conjugate. So I'm going to go ahead and write this out. I want this to be written in your note. You're going to multiply by the conjugate. And what the conjugate is going to be your denominator. So if your denominator was, in this case, 5 plus square root of 2, your conjugate is going to be 5 minus the square root of 2. So instead of that addition sign, we're going to use a subtraction sign. So you're going to multiply both the top and the bottom by that conjugate. Okay? So when we do that, it's going to change things up a little. Okay? On the top, what I have is 3 times 5 minus square root of 2 over 5 plus square root of 2 times 5 minus square root of 2. We need to go back to our multiplying a monomial by a binomial and multiplying our binomial times a binomial. So on top I have 3 times 5, and all I'm doing is I'm distributing through this 3. 3 times 5, which is 15, and then 3 times negative square root 2, which is negative 3 square root 2, all over, and now I'm going to multiply through this, and I'm going to have to double distribute. So I'll have 5 times 5, which is 25, 5 times negative square root of 2, which is negative 5 square root 2, and then square root 2 times 5, which is positive 5 square root 2, and then square root 2 times negative square root 2, which ends up giving me a negative 4, or excuse me, a negative 2. So now what I need to do is I need to go ahead and simplify. So combine like terms on my denominator and on my numerator. Well, my numerator stays the same. It stays 15 minus 3 square root 2. If we look at my denominator, I have a negative 5 square root 2 and a positive 5 square root 2, so those cancel out, they're opposites, and I'm left with 25 minus 2. I can continue simplifying. The top will still be 15 minus 3 square root 2 over 25 minus 2, which is 23. So a quick reminder, what we did is when there's a binomial in the denominators, like how I have here, this 5 plus square root of 2, I'm going to multiply by the conjugate. And the conjugate is my denominator with its opposite sign. So instead of 5 plus square root 2, My conjugate is 5 minus square root 2. If I had a problem, you don't need to do this, but if I had a problem like 6 over 3 minus square root 5, in order to get rid of my denominator, I would multiply by the conjugate, which was 3 plus square root of 5. So all I'm doing is changing that sign in between. Okay? All right, here are your 3 U-tries. Go ahead, try them out, and bring your work and any questions you have to class tomorrow. Good luck.